Hello guys, welcome back. This is Rosario Borgesi and in this video we will explore the control structures and the error handling in Solidity. We will discover the various statements of the control structures like the if-else statement or the while, for, do while loops or the continue, break and return statement. We will also take a look at how the errors are managed in Solidity by means of the panic or the basic error. We will also take a look at the function revert, require and assert, and we will also explore how to use the try catch block to catch the errors. We will make a lot of Solidity examples and we will use Remix to test our code. So I hope that this video will be useful and let's get started. This is a Medium article that I have created to guide us throughout the video that you will find in the description. And here there is a brief introduction of the various control structures that you can have in almost all programming languages like Java, Scala, Python, JavaScript, whatever. And you have basically 4 types of control structures. Each one it is used to perform a specific type of operation. There is the sequential control structure where you execute the instruction in the order they appear in the script, which is the default control structure. Then you have the selection or conditional control structure. For example, with if statement, you execute a certain set of statements if a condition is met or if a condition is true. And then you have the if-else statement that like the first one, when the condition is true, you execute the if statement. If the condition is false, then you will execute the else statement, so you will execute the instruction inside the else statement. Then you have the iteration or loop control structures, which are, for example, the for, the while, and the while loops that allow a set of instructions to be repeatedly executed until a certain condition is met. And then we have the jump control structure that will alter the execution flow by moving the control to another part of the program, like the break, continue, and return statement. We also have the try catch statement that is used to execute some code when a specific exception is thrown. And but in Solidity it can also be used in the case of external functions call. Now let's give a quick look at each of these statements, and later on we will have a practical demonstration. So the if statement is executed to specify a block of code to be executed if the specified condition is true. So for example, if we have that x is greater than y, we will execute this block of code. The else statement is used to specify a block of code to be executed if a condition is false. For example, like before, if x is greater than y, we will execute this code. Otherwise, if x is equal or less than y, we will use this other block of code. Then we have the while statement. The while statement will execute iteratively. It is also called the loop. For this reason, iteratively a block of code while a condition is met, which means that as long as x is less than 10, we will execute this block of code, and most of the times, but not always, at the last line of the while loop, you will find you will increment the variable of 1, the variable on which you are checking the condition. This This we will see better in a while. And so once the x variable gets equal to 10, this loop will not be executed. So here we have a practical example to check how this variable x gets incremented in a while loop. And to test this, we can make use of the Hardhat console.sol contract, because in the blockchain it is not like in the other programming language where you have where you run the program inside a machine and you can print the result in the console. In the blockchain, the execution is decentralized, which means that to print in the console is a more tougher task to do, but nonetheless it can be done anyway by means of this this console.sol contract. In order to use this control.sol contract, we should execute a local blockchain which is provided by Hardhat, and we can do so just by creating a new project with these 3 steps here. For example, let's create a new terminal at the desktop. Okay, then we will make use of this instruction that we have here on the left. So we create a new directory with make dir, for example, hardhat console. Okay, we change the directory to hardhat console. Okay, then we create a new npm project with npm init -y. Okay, it will create a new npm project. Then we download the dependency of Hardhat. So npm install -d, which is equivalent to this expression here, Hardhat. Okay. Okay, that's finished. Now we can start our Hardhat project with npx hardhat init. Okay. He will ask us what project do we want. We want a basic project because we just wanted to start the local blockchain. So we create an empty, we choose empty r.config.js. Okay. Then we have to change in the r. Here, r.config.js, we can change the Solidity version to 0.8.25. We save. Then we can run the local blockchain with npx px hardhat node. Sorry, I typed a wrong instruction. Okay, this way you can see Hardhat has created the local blockchain. We have a number of accounts which have 10,000 ether each one, and uh, this is useful to test locally the code before you want to deploy it in a test network or a main network. So here we have our local blockchain. And we need this because we want to print this result here. We want to use console.log, so print this variable here x in the console. Okay, because otherwise we cannot do this. For example, if we deploy the code to a test network, this cannot be done, or in the mainnet. So we copy our contract here, and we go to Remix contracts. I create a new contract, my contract.sol, and I will paste. No, sorry, I made a mistake. Okay, not this one. I have another file which I use to make my tests. So we have pasted our code here. We import our console.sol contract. Then we run this test function that will initialize the variable x, which is an integer, to 0. And while x is less than 5, we will print the variable x to the console, and then at last we will increment by 1 the variable x. So when x gets equal to 5, it will exit this while loop. So we can, the code is already compiled. As you see here, we have a version of Solidity 0.8.25. This is the reason why we have put the same version of the compiler in the Hardhat configuration. Here we have the panel to deploy, so here the code is auto-compiled with the same version of Solidity. Here we can deploy the code in our environment. We choose dev Hardhat because we want to deploy the code to our local blockchain that we have started, and we choose here deploy. Okay, so the contract, it has been deployed. Here you get the contract address, transaction from, this is the account. It ends with 2266. 2266, okay, it is it. 0 ether, gas used, block number 1. Okay, we have deployed our code. Now we want to run the test function. We just press here test. Okay, and as we will see, here there is a contract call from our account to, this is the contract account, and here it will print the x variable until the value of 4, because when x is equal to 5, it will exit the for loop. So this is the first example to understand what is doing Solidity inside a for loop. Then we can continue, for example, with another example, which is the do while. The do while is a type of statement that will execute this block of code at least one time, and then we will check this condition. If this condition is met, it will start again to execute the code until the condition is no more met. It is similar to while loop, but main difference is that in the do while, this block of code is executed at least one time, whether this condition is true or not. While in the while code, this condition must be met each time. So this is the basic difference. Then we have the for loop. The for loop is similar to the while loop, but here you have this expressions where in the first expression we initialize the variable that we will use to where we will loop on. Then we express the condition that must be met in order for the for loop to continue to be executed, and then at last we will increment the loop, the iteration variable. This is the variable that counts the number of iteration. Here is a practical example to understand how the for loop works. For example, here we are just printing the I variable. So this variable will be this for loop will be executed until the I variable is equal to 5. So it should print from 0 up to 4. So if we copy this code here, we paste it in our Remix console, we deploy it another time, so we should find the new contract deployed here. Then we can call the test function, okay, and we see also in this case that it will print from 0 to 4 as expected. Fine. Of course, you can a for loop can be equivalent to a while loop. For example, if here I initialize outside the while loop the I variable, I want to loop here until I is less than 10, for example, and here I increase the value of the I variable. This is totally equivalent to this for loop here. So there are certain certain moments where we want to use the while loop, and other moments where we want to use the for loop, but there are sometimes where the while loop is equivalent to the for loop. Then we have the break statement. The break statement will exit from this loop. So this means that when we are making a for loop from I that starts from 0 up until I is equal to 9, and when I is equal to 5 we should go out from the for loop, so the loop should not be executed anymore. So here is an example to test this break statement. So when I is equal to 5, it should go out, it should stop executing the loop. So we should print the value of I until 4, because when I is equal to 5, it will go out from the loop, it will not execute the statement here. And also this can be tested in Remix. So as before, we deploy the code it is deployed. Check out that each time we deploy a new contract, it increases the number of blocks because we are deploying to a blockchain. So we run the test function, okay, and it will print up until the value of 4. So it will go out from this for loop, it will quit at the value of I equal to 5. Then we have the continue statement. The continue statement will jump to the next iteration. So while the break statement will completely quit from the for loop, the continue statement will jump to the next iteration. So here, for example, we expect that the value of I equal to 5 will not be printed, because when I is equal to 5, it will go to the next iteration. which means that I will be increased, so we will have I equal to 6 and I equal to 5 will not be this statement here for I equal to 5 will not be executed. So this is another example that we can try. Okay, so let's here I this button is used to remove the instance from this panel, but it will not remove the contract from the blockchain because, as you know, the contract once deployed it is immutable. So here we remove just from our view panel. We deploy another time the contract. We check that here the contract has been deployed. We call the test function, and here we will see that the I equal to 5 is not printed. Then we can give a look to the return statement. The return statement is used to return a value from a function. So for example, here, if we have a function called add that basically performs the sum between two integers, it returns a value uint. So here we are specifying that we are returning this value here sum, and this is this we can also, for example, give a try. Very easy. So we can deploy this contract. For example, here we want to call the add function with the x equal to 5 and y equal to 7. For example, add, it will return 12. Okay? And now here I have written a more comprehensive example that will cover all the statements that we have discussed before, but with more complex and meaningful examples. So here, for example, you have the function is positive that receives an argument x. If x is is positive, so it is greater than 0, it will return true. Otherwise, it will return false. Then we have another example. This example was, of course, to demonstrate the if-else statement. Here we are demonstrating the while statement. So we are calculating a recursive sum from the number that we have received here as an input. If you would like to understand how this works, maybe we should deploy this code. So I want to deploy the code to Remix so we can understand better how it works. So we can deploy our code here. Then, for example, we can call the function is positive that we have discussed before. We pass, for example, 10. It is true because it is greater than 0. If we pass, for example, minus 5, it will give us 4 because it is negative. Here, recursive sum, if, for example, pass a value of 1, it will give you sorry, I made a mistake. Recursive sum here. It will give us 1. If we call it with 2, it will give us 3 because it will make the sum of, for example, if we give it 2, it will make 2 plus 1. So it will sum recursively going backward until the decreasing each time the number until it goes to 0. For example, here if we put 3, it will give us 6. Okay, with 4 it give us, for example, 10 because it's 6 plus the new number 4 which is 10. Okay, and this is how we are demonstrating here the while statement. Then we have a demonstration for the do while statement. So if we, for example, here give in the do while statement, which is sum backwards, here we give it 1, it will return 1. If we give it 2, it will return 3. If we give it 3, it will return 6. It is the same as before. If we give 4, it will give us 10. So each time it is, for example, for 4, if I take a calculator, it will do for 4, 4 plus 3 plus 2 plus 1. And this is the same for the do while loop, so for this function sum backwards, and for this function here recursive sum that demonstrates the while statement. Then we have also another example with to demonstrate the factorial. So for example here if we want to run the factorial, we should call factorial function. For example, the factorial of 1 is 1, the factorial of 2 is 2, the factorial of 3 is 6, the factorial of 4 is 24, because it would be the factorial of 1 is just 1, the factorial of 2 is 2 per times 1, so you multiply for the present numbers, the previous numbers. So, for example, the factorial of 3 would be 3 times 2 times 1, which is 6. The factorial of 4 will be 4 times 3 times 2 times 1. Okay, so we have demonstrated also the factorial. Then this is for the for statement. Then to demonstrate the break statement, here we'll make a count that here we are increasing basically the I variable until x is greater than I, but when I is equal to 5, it will stop the count. So here, for example, in the function stop count at 5, if we pass 1, we get 1, 2, we get 2, 3, we get 3, 4, we get 4, 5, we get 5, 6, we get always 5, because when I is equal to 5, it will break, it will go out from the while, it will not execute it again. So if we have put here 7, it will also give us 5. So this is an example of the break statement. Then we have the continue statement. Here, for example, here the skip sum of 3. If I pass it here 1, it gives us 1, 2, it gives us 3. If I put here 3, it will give us also 3, because here when I is equal to 3, it will not perform the sum. So it will go to the next iteration, but if we put here 4, it will give us 7. Okay, because only for y equal to 3, the sum here is not performed. We are basically summing here the I variable. So, because as you can see here, they are both initialized to 0. Here each time we increase the value of the I, and then we sum it to the present, to the previous values. Here we have also an example of how to perform some tests, for example, with the assert statement that we will discuss later on. For example, here test is positive, we pass value of 5 to the function is positive, and we expect that the result is equal to true. Here we pass to is positive minus 5, we expect that the result is false. Of course, if this condition is not met, it will throw a panic error, as we will see later on. So if we run, for example, test is positive, it will here it means that it is the function it has been called it has not thrown any exception. Here, for example, we are testing the recursive sum that we have seen earlier, which is this one, to demonstrate the while statement. So that is doing the sum of all the previous numbers that we give from the number that we give an argument. It sums all the previous numbers before it until 0. So for example, the recursive sum is 1 is expected to be 1, the recursive sum of 2 is expected to be equal to 3, of 3 is expected to be equal to 6, of 4 is expected to be equal to 10. Also here the recursive sum it is executed without error. Here also we are demonstrating the factorial. So the factorial of 0 is 1, the factorial 1 is 1, of 2 it's 2, of 3 it is 6, of 4 it is 24, of 5 it is 120. Also the test factorial function here can be executed. It goes fine. The test sum backwards here that sums it is similar to this one. So also these are all just tests that we make to make sure that the function we have written are functioning correctly. Also here stop count at 5. As you can see from the number that are greater than 5, the number the count we expect that it is always equal to 5 from 5 onwards, because at 5 there is a break. So it is this stop count at 5, we have a break at 5. So here we can run also this test. Okay, and then we have the test skip sum of 3 when I is equal to 3, it will not sum the number. So here we have that the function at 2 gives the same result of the function evaluated at 3, which is always 3. So if we run a test skip sum at 3, here it gives us an error. Because here it should be 5 and not 4. So if we here deploy this function again, here the test skip function test skip sum at 3. Okay, now it works. So as you have seen earlier, when the function when the assert is not valid, it will throw an error. Here, as you can see, exception, while the processing transaction reverted with panic code 01 assertion error. This we will see later on. So now that we have redeployed the contract, this test function works. So let's now move back to move to another topic, which is the topic of error handling. Here we are describing in this paragraph the assert, require, revert function and the exceptions. Basically, in Solidity, exceptions are used for error handling, much like in Java, and they can occur both at compile time and at runtime. Compile time is very simple. For example, if here I write return, I drop this letter, you will see this is a compile error. This is an error of compile time. So the code will not compile until we don't solve the error. And we can also have errors at runtime that are much more different, much more difficult to resolve. And for example, at runtime, we can have errors like out of gas error. For example, if we don't have enough ether to run this our code, data type overflow error, divide by zero error, or array, for example, out of index error. Maybe the only error that you have not seen in other programming language is this one, or data type. No, only this out of gas error. So exceptions that occur in subcall will automatically propagate upwards, which means that if we have a function, two functions, for example, a function A that inside calls a function B. If the function B throws an exception, it will be propagated upwards to the function A, unless they are intercepted by a try-catch statement that we will see later on. If there is no try-catch statement, it will go up to the higher level function. It will cause the function to throw an exception and execution will be stopped. And this is very similar to Java. The only exception to the rule are the function here send call and delegate call and static call that we return false if in the case of exception. So exception, like in other programming language, carry the error information, so why the execution has been stopped or what has caused the error. And there are two types of error, which are the error here the error exception and the panic exceptions, and they can be utilized by specific functions, for example assert, revert, and require. So the typical error that we should use to deal with standard error situation is this error here, while the panic error is used for errors that should not occur if our code is free of bugs. So we should not have any panic error in our code. So let's talk about the assert function. So the assert function is utilized to verify condition and will trigger an exception if the specific condition is not fulfilled. The exception that is thrown is of type panic. So the assert function should be exclusively used for internal error testing and invariant checking. Code that is functioned correctly should never produce a panic error, even in response to incorrect external input. So if a panic error is generated, it indicates a bug in your contract that needs to be addressed. So when a revert is triggered, this means that when the assert statement triggers a revert, all changes made to the if-when state are reverted. So these are the situations where a panic exception is generated, and the error code supplied with the error data indicates the kind of panic. So for example, if the code is 0x00, this is in hexadecimal code. This is used for generic compiler inserted panics. 0x01, this is thrown when we call assert with an argument that evaluates to false. So basically, as we have seen, if you recall earlier on Remix, when we have called the assert that evaluated to false, it had produced an error of type 0x01. So then we have if an arithmetic operation results in an underflow or overflow outside of an unchecked block, it will produce the error 0x11, 0x12 in the case of division or modulo by 0, and so on. For example, 0x31 if we call the method pop on an empty array. This is the whole list of code that you can find in the whole list of errors that can be thrown by the panic exception. Here, for example, there is an exception, two examples where panic error can be thrown. For example, here, if we pass as the value of x as 0, here it will throw an exception. Is here if we divide the number for 0, also here it will, in both cases, it will be returned a panic error. So, for example, this is the transaction, the receipt that you get when executing, for example, this function here, example function with 0 as parameter, and this is the return, the transaction receipt that you get when you call the divide function with y equal to 0. So here is telling you execution reverted, assert false. Here is telling execution reverted, division or modulo by 0. This is an example that I've created to demonstrate the code that is the error code that we were talking about. So these are the same function as before, example function divide. I have also added the pop array function that calls the pop method in an array that is empty here. It is only defined, but we haven't added any element. So here we are calling, for example, here the test example function. We are calling the example function here with this notation. So this is an external function, so we must call it this way, and we are providing as an argument 0. So if this function, example function, throws an error, a panic exception, only if it is a panic exception and not an error, it will be executed this block of code. Otherwise, if not, it will be executed this code here. And in this case, the test will always fail. And so this is the try catch block. It is used to catch the exceptions, as we will see later on. we will, in this case, we are catching for the specific panic exception, but we could also catch an error exception or whatever exception this this code here is throwing. So if this code does not throw any exception, it will be executed this statement. If this instruction here will throw a panic exception, it will get executed this block of code. If it is executed another type of exception, or for example error, nothing of this code will be executed, and it will the function will throw simply an error exception, and it will fail. So here we are demonstrating with this assert that the error code that is throwing this function is 0x01, which is the one we have discussed in this case, okay, because we are calling assert with an argument that evaluates to false. And then in the other case here, test pop array, we are calling the pop array function, and we are expecting here to receive an error code of type 0x31, which we are testing here. Please bear in mind that also in this case, if the error, this function do not throw any error, the test also in this case will fail. Will fail always only if the test will be passed only if the function throws a panic error of type or with error code 0x31, and also in this case the test will be passed only if the panic error thrown by this function is of type 0x01. Then we have the test divide function, in which we are calling, we are making a division by 0, and here the test, it is passed only if this function here throws a panic error of type with error code 0x12, which is the one expected also here that we have discussed here, okay? And so we can try this code here in also in Remix. Okay, for example, here if we call the example function with 0, sorry, I need to deploy this code. Call the example function with 0, it will return a panic error of type 0x1. Same for this other function here. If I call, for example, pop array, send a transaction, okay, it will return with a panic code 0x31. And if I call divide by 0, it will throw another panic error type 0x12. So if I call the test function that we have described before, they should all go fine, because we are checking the right error code. So it all went as expected. Now let's talk about the require function. The require function is used for input validation. It checks whether a certain condition is true, and if it's not, it reverts all changes made to the state during the current call, and will also provide an error message. So the require function provides three overloads, which are require, which revert without any data, in this case, if use this. Then we can use require, where we provide the string error that will be put inside this error here. And then we have another type of overload, which is require bool error that will revert with a custom error, a user supplied error. Okay. Then we have so when it is thrown an error exception is thrown in by the compiler in the following condition: calling require where x evaluates to false. If we use revert or revert description, which create an error, and if we perform an external function call targeting a contract that contains no code, if our contract receives either via public function without payable modifier, if our contract receives either via a public getter function. So for the following cases, the error data from the external call is forwarded. This means that it can either cause an error or a panic. So if the method .transfer fails, if we call a function via a message call but it does not finish properly, for example, if it runs out of gas, has no matching function or throws an exception, and this does not apply to low-level operation like call, send, delegate call, call code, and static call, because they return false in case of exception, or if we create a contract by using the new keyword, but the contract creation does not finish properly. We can optionally provide a message string or a custom error to require, but not to assert. If we do not provide a string or a custom error argument to require, it will revert with empty error data, not even including the error selector. So in our code, of course, it is advisable to throw error that contain a meaningful message, because this will help us understand why the execution was interrupted. And similar to the assert function, also when a revert is triggered internally in Solidity, all changes made to the if-when state are reverted. Additionally, like before, we can catch the error thrown by a revert statement by means of a try-catch block. So this is an example of how to use the require function. Here, for example, we require that the denominator must be greater than 0. So if the y is equal to 0, it will throw an error. So for example, if we call this divide function with x equal to 10 and y equal to 0, we will see this login remix. The execution reverted, the denominator must be greater than 0. So it has thrown an error with this message here. So to prove that that the revert statement is throwing an error of type error and not, for example, a panic error, we can make use of the try-catch block. For example, in this case, we have also our the divide function that we have discussed earlier, and we call this divide function, and we are dividing by 0, and we are asserting with this is a function that it is used to compare the two strings are equals. We are making sure that here the message is of type error. So the error must be of type error here. When we call divide by 0, we are asserting that the message is exactly error. Sorry, there was a mistake here. Here, the message, of course, should not have been error. Instead, the error denominator must be greater than zero because we are throwing here an error with this message. So here we expect to match the same description, the same error message here that we are throwing with this require. So if we try to deploy this on Remix, okay, we deploy our function and we call test divide. Okay, it works. If we call divide by 10, it will throw an error. So it throws an error here, reverted with reason. The denominator must be greater than zero. Okay. So here we are making sure that this function can only will when called with 0 as y will throw an error with this message of type error. In all the other case, the test will fail. Okay. So let's pass to the revert statement. And to force a direct revert during a function execution, we can use the revert statement. It takes a custom error as a direct argument without parentheses, for example, in this case. But for backward compatibility reason, there is always the revert function which accepts a string as an argument, like in this case here. So the error data will be passed back to the caller and can be caught with a try-catch statement. Using revert causes a revert without any error data if we do not provide a description, while if we provide a description, it will create an error string. So using a custom error instance will be usually much cheaper than a string description because you can use the name of the error to describe it, which is encoded in only for bots. This is an example of throwing a custom error. Okay, this is a new error that we are defining, that it is number not valid, and we are if y is equal to 0, we are forcing this execution to throw this custom error number not valid. So this can also be tested in Remix. So if we we deploy our code, if we call divide by 0, it will throw an error reverted with an unrecognized custom error. Okay, this is because we are testing it in our local blockchain, but otherwise, if we test it for example, in Sevolia, it will the transaction will return execution reverted. The transaction is being reverted to the initial state. Error provided by the contract number not valid parameters. Okay, so this is in this case, we are also testing that the revert function throws an error of type error here, and like before with the require here, we are making a similar test because here this method compares two strings if they are equal, and we are asserting that the message error is equal to the one we have placed here inside the revert function, so we can test also this code. So if we deploy it and we call, for example, test divide, and it works. For example, 10, we pass 10 and 0, it will say, okay, an error occurred, reverted, transaction reverted with reason string, the denominator must be greater than 0. Okay, message of type error. Okay, and so the require, this condition require y greater than 0, and we provide this error message is equivalent to if y is equal to 0, revert with this error. So we can express it, we can use the require or the revert function, they are equivalent. So let's talk about the try catch block. We have seen two examples before of try catch block where we were catching for a specific type of error or panic error. And but of course there are also other cases of using a try catch block. So as earlier we can catch an error, panic, but we can also use um, these two catch statement here if this is executed if the error signature do not match the other clauses and provides a low-level error data. Okay, and this also, these two catch statements are executed if the other catch statement do not catch the error. Okay, so it is a catch all. Any type of error will end up here. But while in this case we get the bytes, the low-level bytes, here we get nothing. So we can say that the try catch statement can be used to, for example, check some specific some failures in an external call, and of course the try keyword must be followed by an expression representing an external function call or a contract creation, for example, with new contract name. The errors inside the expression are not caught. For example, if it is a complex exception that also involves errors inside the expression are not caught. For example, if it is a complex expression that also involves internal function calls, only a revert happening inside the external call itself. There is also a returns part which is optional, and if the end of the success block is reached, the execution continues after the catch block. Solidity supports different kinds of catch blocks depending on the type of error, as we have seen earlier. The catch error, which is executed, for example, if the error was caused by revert or require. The catch panic, if the error was caused by a panic, for example, an assert division by 0 and so on. Catch bytes memory low-level data. This clause is executed if the error signature does not match any other clause, if there was an error while decoding the error message, or if no error data was provided with the exception, the declared variable provides access to the low-level error data. Then we have the catch without any a simple catch. If you are not interested in the error data, just use catch even as the only catch clause instead of previous clause. So in order to catch all error cases, we could use either catch here or the clause catch bytes memory low-level data. So here it is an example where we demonstrate that here, for example, we are throwing an error a custom error which cannot be specifically catched like with error or panic, and we will demonstrate that it will execute this block here, so the low level data length is different than 0. We can execute this code here. Sorry, I lost the two first conditions. So we have pasted the code here, and we can so if this, for example, this function here throws an error of type error, the test fails. If it is a panic error, the test fails. And if throws no error, the test fails. Only if it is executed, this catch here, the test is passed. So if we try to deploy this contract and we call test divide, okay, the test is passed, so it is true. Okay, then we have here we are testing the simple catch clause. Like before, we are testing that only this block here it is executed while the other blocks not. We can also paste this code here. We deploy it, and then we call test divide. Okay, and the test is passed. So we have reached the end of the video. I hope that it has been useful. If you have any questions or if you have any suggestion to improve my future videos, I suggest you to leave a comment, and I will answer to you as soon as I can. And thank you for watching, and see you in the next video.